You are a DBA. It is 3 a.m. Your monitoring fires, table bloat, orders table, 47 gigabytes, should be 12. You check pg_stat_activity. Autovacuum is running, on the sessions table. Sessions has 200 dead tuples. Your orders table has 18 million. Why is Autovacuum cleaning sessions instead of orders? Here is the plan for this video. First, we cover the pain why Autovacuum has been a black box. Then parallel workers, what they do not do, and how to size them. Next, the scoring system. This is the biggest change. pg_stat_autovacuum_scores tells you exactly why a table is queued and lets you control the priority with 5-way GUCs. Then observability, the new columns in pg_stat_progress_vacuum. Configuration you can copy-paste. And honest gotchas including the memory math you must do before enabling any of this. Stay to slide 16, I will give you the complete monitoring dashboard query for PG19 Autovacuum. 1 query. Everything you need. Let me show you the 3 problems that every PostgreSQL DBA has felt. Problem 1, no priority. Autovacuum scans PG_class and PIX tables in OID or discovery order. A table with 18 million dead tuples waits behind a table with 200. You cannot control this. Problem 2, no visibility. Why did Autovacuum choose that table? Is it freeze pressure? Dead tuples? Insert bloat? The answer was, check thresholds manually, do the math yourself, guess. Problem 3, single-threaded index cleanup. Each Autovacuum worker processes indexes one by one. If your table has 8 indexes, a couple of B trees, a GIN on John, some partials, one worker cleans them serially. The GIN index alone can take 80% of the time. Let me show you the 3 problems every PostgreSQL DBA has felt. Problem 1, no priority. Autovacuum picks tables in discovery order, not by urgency. A table with 18 million dead tuples can wait behind a table with 200. Problem 2, no visibility. You cannot see why a table was chosen or how long it will wait. Problem 3, single-threaded vacuum on large tables means one worker crawls through gigabytes while the queue grows. PostgreSQL 19 targets all 3. 2 GUCs control this. Per table, alter table huge_John_thing set Autovacuum_parallel_workers equals 2. This is the right way, enable on specific tables where you have measured long index cleanup. Cluster-wide cap, Autovacuum_max_parallel_workers. Set this to at least the largest per table value you have. Workers come from the max_parallel_workers pool. The same pool your query parallelism uses. So you need headroom. Here is the decision framework. Table has 1 to 2 indexes? Leave it off. 0 benefit. Table has 4 or more indexes, especially GIN or GIST? Set to 2, benchmark. Storage is NVMe or GP3 with headroom? Parallelism helps. Storage is IOPS limited? Adding workers just queues I/O. Rule of thumb, 2 is usually plenty. 4 is aggressive. Higher than 4 is almost always I/O queuing, not speedup. I need to be honest about this. Look at the 4 phases of vacuum. Phase 1, heap scan. Builds the dead tuple list. Single-threaded. Phase 2, index cleanup. Removes dead pointers from indexes. This is the only phase that goes parallel. Phase 3, heap cleanup. Marks dead tuples as free. Single-threaded. Phase 4, truncation. Single-threaded. If your vacuum is slow because the heap scan is slow reading millions of pages, parallel workers do absolutely nothing. And vacuum is overwhelmingly I/O bound. The index pages have to be brought in from disk. If your storage subsystem is already pinned during a single autovacuum on one large table, adding 3 more workers does not unpin it. They are all queued behind the same disk. This is the situation on a great many cloud Postgres instances. Managed RDS or Cloud SQL with provision IOPS in the low thousands? Parallelism gives you the same total throughput, more context switches, and more worker slot consumption. Both conditions are required, lots of indexes and storage that can keep up. Now the biggest change. The scoring system. PG_stat_autovacuum_scores is a new system view in PostgreSQL 19. Look at this terminal output. Order scores 0.87, highest priority. Why? Because vacuum_score is 0.65, that is dead tuple pressure. Freeze score is only 0.12. Now you know, orders is first because of bloat, not because of wraparound risk. Audit_log scores 0.62. Insert score is 0.45, it is an append-only table. Lots of inserts without vacuum. Users scores 0.43. But look, freeze_score is 0.38. That table is under freeze pressure. Before PG19, you could not see any of this. Autovacuum picked tables by discovery order and you had no way to know why. Now every decision is visible. 5 new GUCs control the scoring weights. All default to 1.0. Autovacuum_freeze_score_weight, how much XID age matters. Higher means freeze urgency tables jump the queue. Autovacuum_multisact_freeze_score_weight, same but for multisact age. Autovacuum_vacuum_score_weight, how much dead tuple count matters. This is the bloat signal. Autovacuum_vacuum_insert_score_weight, how much insert without vacuum matters. Append-only tables. Autovacuum_analyze_score_weight, how much statistics staleness matters. Bad stats means bad plans. The practical tip, if you have ever panicked about XID wraparound, increase the freeze weight to 2.0 or higher. Freeze urgency tables will jump ahead of bloated tables. This was impossible before PG19. Let me show you a real example. Left side, default weights, all 1.0. Order scores highest at 0.87 because of dead tuples. Legacy_data is third at 0.43, but look at its freeze score, 0.41. That table is at 85% of freeze_max_age. It is a wraparound risk. But it is stuck behind 2 bloated tables. PG_stat_progress_vacuum gains 2 new columns. Started_by tells you who initiated the vacuum. Manual, you ran vacuum yourself. Autovacuum, the launcher triggered it. Wraparound, emergency anti-wraparound. Before PG19, all of these looked the same in PG_stat_activity. Mode tells you the aggressiveness. Normal, routine cleanup. Aggressive, visiting all pages for freeze scan. Failsafe, emergency, autovacuum_freeze_max_age exceeded. One column answers the question, is this an emergency? Also new, PG_stat_progress_analyze gets started_by as well. And vacuum verbose now logs both the planned and actual number of parallel workers. The two diverge often, max_parallel_maintenance_workers, min_parallel_index_scan_size, and runtime worker availability all gate the count. This is the slide I promised. The complete PG19 Autovacuum monitoring dashboard. One query that joins PG_stat_autovacuum_scores with PG_stat_user_tables in PG_class and left joins PG_stat_progress_vacuum. You get table name, composite score, individual scores, freeze, vacuum, insert, analyze, dead tuple count, life tuple count, XID age, last auto vacuum time, and if a vacuum is running right now, its phase, who started it, and what mode. Everything. One query. Copy this. Add it to your monitoring stack. Grafana, Quatch 2, Canalize, all can pull this. Set an alert on mode equals failsafe. That is the emergency signal. Same DBA. Same problem. Different tools. PG 10 through 18, table is bloated. Why isn't Autovacuum running? Check PG_stat_activity. It is on a different table. Why that table? Discovery order. Is this vacuum for freeze or cleanup? Unknown. Lower thresholds. Increase workers. Hope. PG19, table is bloated. Check PG_stat_autovacuum_scores. Orders scores 0.87. Why? Vacuum_scores 0.65, dead tuples. Is it freeze? Check mode column, normal. Adjust freeze_score_weight. Reload. Verified. Index cleanup slow? Parallel workers. Measured speedup. Same problem. But now every question has a concrete, queryable answer. Before you enable parallel workers, do this math. Worst case memory, Autovacuum_max_workers times Autovacuum_max_parallel_workers times maintenance_work_mem. 3 workers times 4 parallel each times 1 GB maintenance_work_mem equals 12 GB. Just for Autovacuum. If you have maintenance_work_mem set to 4 GB and enable 4 parallel workers across 3 Autovac workers? 48 GB. Redo the arithmetic before you upgrade. Here is a safe starting point. 3 Autovac workers, 2 parallel, 256 MB maintenance_work_mem. Worst case, 1.5 GB. Parallel slots, 6 out of 12. Leaves 6 for query parallelism. Start conservative. Monitor. Increase only where duration drops. 2 diagnostics. Takes 30 seconds. First, check PG_stat_progress_vacuum during an auto vacuum on the target table. If you see multiple PIDs on the same table in the vacuuming indexes phase, that is the leader plus your parallel workers. It is working. But if the workers appear and disappear quickly while the leader stays in the heap scan phase for most of the run, you are looking at a table where parallelism was not going to help. The bottleneck is heap scan, which is single-threaded. Take it back off. Second, compare auto vacuum duration over time from PG_stat_user_ tables. If durations do not drop after enabling parallel, the feature is not doing what you wanted. The slots could be put to better use elsewhere. Vacuum verbose now logs both planned and launched parallel workers. Check both, they diverge often. Autovacuum is the headline, but PG19 is a maintenance and operability release. For more changes worth knowing. 64-bit multi-zact. The 32-bit counter that caused vacuum or die emergencies is gone. Widened to 64 bits. Repack concurrently. In-core table rebuild without access exclusive lock. Replaces the PG_repack extension. Concurrent reads and writes during rebuild. Query-driven visibility map. Table scans can now mark pages as all visible. Less work left for Autovacuum. Default LZ4 toast. Faster compression means less CPU during heavy inserts. Every pain point DBAs have complained about for years got attention in this release. 6 honest limitations. Know these before you configure. 1. The scoring system is new. Default weights are all 1.0. They may not match your workload. The PostgreSQL hackers mailing list debated whether the defaults sufficiently prioritize freeze urgency. Expect to tune. 2. Parallel is off by default. You must explicitly enable it. Per table is safer than cluster-wide. 3. Heap scan is still serial. If that is your bottleneck, parallel gives zero benefit. 4. I/O saturation. Parallel workers on I/O saturated storage equals more queuing, not more throughput. 5. Worker slot contention. Aggressive parallel settings starve query parallelism. 6. Score weight caps. The initial discussion capped weights at 1.0. The final patches allow higher values. Check your PG19 build. None of these are deal breakers. All of them are worth knowing. Here is the configuration I recommend as a starting point. Parallel, Autovacuum _max _parallel workers equals 4 as a cluster-wide cap. But do not set Autovacuum _parallel workers globally. Use alter table on specific tables, the ones with many or expensive indexes. Scoring weights, freeze at 2.0, multi-exact freeze at 2.0, because wraparound is more dangerous than bloat. Vacuum and vacuum insert at 1.0. Analyze at 0.8, slightly deprioritized because statistic staleness is rarely as urgent as bloat or freeze. Headroom, max _parallel workers 16, max _worker processes 24. Memory, maintenance _work _mem 256 megabytes. Worst case, 3 times 4 times 256 equals 3 gigabytes. Copy this. Tune from here. Every cluster is different. 3 changes. All production significant. Parallel workers, index cleanup in parallel. Off by default. Enable where it matters tables with many or expensive indexes. Scoring system, PG_stat _autovacuum _scores shows you why each table is queued. 5-weight GUCs let you control priority. Score order replaces discovery order. Tune, do not hope. Observability, started _buy-in mode in progress views. Manual versus auto versus wraparound. Normal versus aggressive versus failsafe. Bottom line, Autovacuum has been a black box for 20 years. PostgreSQL 19 opens it up. That is the full walkthrough. 19 slides. Parallel workers, scoring system, observability, memory math, configuration, monitoring queries. If you manage PostgreSQL in production, subscribe. I make practical videos on performance, backups, replication, security, and migrations. No fluff. Just the details you need. Comment vacuum and I will drop the complete monitoring query and configuration template in the pinned comment. Hit subscribe. Hit the bell. I will see you in the next one.